Okay, our first example here is about Egg McMuffins. Assume that the calories in a McDonald's Egg McMuffin is normally distributed variable with a mean of 200 calories and a standard deviation of 14 calories. A normally distributed random variable. We're given the mean and we're given the standard deviation. What is the probability that a particular serving contains fewer than 300 calories? So what is the probability? I got a normal distribution. I got an average of 290, standard deviation of 14. And question is, what is the probability that a particular serving contains fewer than 300 calories? Now, with the standard deviation of 14, the fact that 300 is 10 units from 90, I'm going to say 300 is probably about right in there somewhere. So my interval that I want the probability for is basically from negative infinity up to 300. And the probability of being in that interval, the answer to this question is the area under the density function above the interval. To translate this into what's called standard normal, what we were talking about in our last video, where we can use the table, translate my problem here into standard normal. And to do that, I need the z-score. So the z-value for the upper end here of the interval, 300. I'll subtract the mean from that. How many standard deviations is 300 from 290? I'll divide by 14 and get 0.71. And so I need to go to the table then and look up 0.71. So 0.71, my z-value is 0.71. So I'm going to go down to row 0.7 and over to column 0.01. So I get a 0.2611. So this area here is 0.2611. Now that tells me that this part right here is 0.2611, and what we already know is the normal distribution is symmetric. The left and right sides of that vertical line going through the center have the same area. Total area under the curve is 100% or 1. So this side of the curve would be 0.5. So my answer would be 0.5 plus 0.2611, which is 0.7611, or 76.1%. So to answer the question, what is the probability that a particular serving contains fewer than 300 calories? Well, there's a 76.1% chance of that happening. Or of the Egg McMuffins that you order, 76.1% of them have fewer than 300 calories. Okay, for part B, what is the probability that there is more than 250 calories in a particular serving? So the probability that X is greater than 250. So my interval here, notice again the standard deviation is 14. So going down to 250 from 90, I'm going to be way down here someplace. So 250 and more than. So my interval is this one. So in other words, 250 to infinity. And to solve this one, I'm going to need to get a z-value. So what is the z-score for the endpoint here, the 250? So subtract the mean. How far away is that 250 from the mean? In standard deviation units. So that turns out to be minus 2.86. Notice the resolution of the standard normal table is in hundreds, so I rounded that to 0.86. Now, how am I going to get this? Well, the standard normal table only calculates or gives us probabilities for areas from the center out to a positive z. So I'm basically going to have to look up the 2.86, and then I'll get a measurement from the center out to that particular value. So 2.86, 2.8, I'm going to scroll down here a little bit, so 2.8 right here, and then 0.06. So I'm going to work across here to 0.06, which would be 0.4979. So this area right here is 0.4979. So basically what I've done is calculated this area, the 0.4. This is by symmetry. And again, I know that to the right of the center is 0.5. So in this case, to get my total area, I'm going to add. So the probability that x is greater than 250 is equal to the probability that z is greater than negative 2.86, which is 0.4979 plus 0.5. And this is kind of done by symmetry. So I get a total of 0.9979 or 99.8%. Okay, we're still working on the Egg McMuffin problem. So this is part C. Between 275 and 310 calories. So the probability that x is between 275 and 310. Now 275 is probably about right there, approximately, and 310 is probably a little further out here. So my interval, right there, and the probability of being in that interval is the area under the density function above the interval. So in this case, I want to translate to standard normal so that I can go to my table and get these values. Now to do that, I need two z-scores. I've got two endpoints here. So let's find the z-value for 275. Again, how far is that from the average in standard deviation units? And then let's find the z-value for 310 and see what these are. So they're negative 1.07 standard deviations to the left. That's the 275, and 310 is 1.43 standard deviations to the right. So I'm going to need to go to my standard normal table and look up both of these. So for the 250, I've got 1.07. Again, these are positive values. 1.07, and that would be 0.3577. And then I also have, for the 310, I've got 1.43, so there's the 1.4, and the O3, so I get 0.4236. So going back here, this standard normal, let's just go ahead and recreate the standard normal here for this one. We've got 0 here in the center, and we've got a negative 1.07 and up to a 1.43. So 0 in the center, a negative 1.07 and a 1.43 in standard units. Standard normal table is in terms of standard deviation units, or z values. Now when I look up the 1.07, I got 0.3577. Now that was to the right, but again, because of symmetry, I know that that part of what I want there is going to be the 0.3577. And this part will be the value I got for the 1.43. So that would be 0.4236. And to get that, right, so in other words, this part of it, my normal distribution, these are going to be the same percentages. I just translated standard normal because I want that one table to work for every problem, translating the problem into standard normal, using the table, and then going back. So that's taking calories, the x, and translating it into the number of standard deviation units. So that would be the probability of being between 275 and 310 is the same for x. The probability of being between 275 and 310 for x is the probability that z is between a negative 1.07 and 1.43. And we add the two values to get that. So 0.3577 plus 0.4236 equals 0.7813, or 78.1%. So what is the probability that a particular serving will be somewhere between 275 calories and 310 calories? There's a 78.1% probability of that, or 78.1% of Egg McMuffins will have calories somewhere between 275 and 310.